Greetings, my name is Barbaros Akkurt and I am from Istanbul Technical University, and my friends Elif Tüzün and Selcan Karatuş are from Istanbul University, Cerrahpaşa. Dr. Nevin Taşaltın is from Maltepe University. Our title is High Performance Non-enzymatic Urea Electrochemical Sensor based on chitosan-coated copper nanospheres. Briefly, we accomplished the following. Chitosan-coated copper nanospheres were fabricated. SEM plus EDX and XRD were used for characterization. Copper sensor had a linear range of 1 to 8 millimolar. Response time was fast, less than a minute. Sensitivity was high. Detection limit was low in PBS under optimum conditions. The proposed sensor shows promise for urea detection in biomedical applications. We used the following chemicals and apparatus: glacial acetic acid, sodium hydroxide, silica gel 230-200 mesh, sodium borhydride, copper sulfate pentahydrate, chitosan 190 to 310 kilodaltons, phosphate buffered saline PBS, electrochemical gold transducers, and photometric electrochemical workstation by Electronics. 4 synthetic steps were used for fabricating copper nanospheres. 20 milligrams of chitosan was dissolved in 100 milliliters of glacial acetic acid at room temperature. 10 milliliters of 10 millimolar copper 2 solution and 10 milliliters of 20 millimolar borhydrate solution were mixed for 20 minutes at 1500 rpm. 20 milligrams of silica gel was introduced into the chitosan solution. Chitosan solution and the reduced copper solution were mixed and sonicated under nitrogen atmosphere at room temperature using a probe type sonicator for 15 minutes. Thin gold 3 electrodes on FR4 electrochemical transducers were employed as working electrode. All electrochemical transducers were cleaned with distilled water and dried under nitrogen. 5 microliters of copper nanosphere solution was dropped cast on the electrode surface and coated at a spinning speed of 1000 rpm at room temperature. Urea detection was performed with the so-obtained electrode. The potential of the working electrode was changed linearly over time. The reference electrode was kept at a constant potential. Using pre-electrode transducers in cyclic voltammetric mode, the current values between working electrode and counter electrode were measured. The range was -1 to +1 volt and scan rate was 15 millivolts per second. The peak current is a function of the concentration of an analyte in the cyclic voltammetric oxidation. Sensitivity of the voltammetric electrochemical sensor could be calculated with the following formula: S equals Ig minus I naught over I naught. Ig and I naught are currents recorded at times of interaction or non-interaction, respectively. Cb was used to analyze and detect the performance of urea detection owing to the quantification of neural states of the analyte in terms of current variations. The sensitivity was calculated with the following equation: sensitivity equals slope of the calibration curve over area of the electrode. Figure 1 shows the XRD results of the chitosan copper at the top, chitosan copper silicide in the middle, and chitosan or copper silicide at the bottom. Figure 2 shows the SME micrograph and the EDX results of the copper nanospheres. Current density versus voltage curves were obtained for the electrodes coated with nanospheres against urea. Now, conclusions. As a conclusion, the following points were drawn. The copper nanospheres were successfully obtained and their electrochemical properties were successfully analyzed. Electrochemical sensors coated with copper nanospheres had a good sensitivity and selectivity towards urea and PBS medium. During a cyclic voltammetric scan of 1 minute, 1 to 8 millimolar urea could be detected with a high sensitivity of 0.91 microampere over centimeter to the -2 millimolar. The lower limit was found to be 100 micromolar. The urea sensors with copper nanospheres had the highest performance for rapid and effective urea detection and could be extended for fabrication of commercial urea test strips with copper nanospheres. Now, references, a total of 37 ones, and most of them are from the last 3 years. And thank you very much for listening to me.